So we made our own tree diagram together, but this one gives us the tree diagram, and then we have to use it to answer the questions, which may sound easier, but it's actually a little trickier, because when you make it, you know what you're looking at, but when somebody else makes it for you, you have to interpret what they're saying. So it says an automobile dealer has cars available with the combinations of colors, engines, and transmissions indicated in the following tree diagram. A selection is made at random. Does it matter if you know what a transmission is? Not really. The whole point is there's colors, engines, and transmissions. I don't care if it's apples, bananas, and fruit trees, or dogs and cats and bunny rabbits. It really doesn't matter. There's going to be one thing chosen from this section, one thing chosen from this section, and one thing chosen from this section. So even if you don't know, don't get caught up in that kind of stuff. Question A says, what is the probability of selecting a car with a manual transmission? Again, it doesn't even matter if you know what that is. So we are looking for a car with a manual transmission. How many manual transmission cars are there? Well, here's one. A red car with a 4-cylinder and a manual transmission. Or I could get a red car with a 6-cylinder and a manual transmission. Or a blue car with a 4-cylinder and a manual transmission. Or a blue car with a 6-cylinder and a manual transmission. So what I want, remember it's want over total. What I want is a manual transmission. How many manuals are there? One. Well, here there's 1, 2, 3, 4. So 4 is your top number. And how many are there total? Remember, we're going to count the ends. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that is 4 out of 8 total. Now we got to simplify that. We can't leave it the way it is. So if I simplify 4 and 8, I can divide them both by 2 or by 4. Four divided by 4 is 1, and 8 divided by 4 is 2. The probability of selecting a car with a manual transmission is 1/2. Now, question B says, what is the probability of selecting a blue car with a manual transmission? So it has to be a blue car. So none of these count because this is all the red cars. Blue car with a manual transmission. So I can go blue 4-cylinder and manual, or blue 6-cylinder and manual. So how many are what I want? A blue car with a manual transmission. 2, right? Here's one, and here's one. So 2 is on top. And do you remember what our total was? Did it change? Did it go down to 4? No, because I could still choose red. I just want blue. So it's still 1, 2, 3, 4, 5, 6, 7, 8. Now simplify by 2. And you end up with 1 out of 4. Feel okay so far? Remember, if this is like rocking your world, get some help with it. You do not have to figure it out yourself. What is the probability of selecting a car with a 4-cylinder engine and a manual transmission? So we don't care if it's red or blue. We'll take a 4-cylinder with a manual or a blue 4-cylinder with a manual, right? So this one just happens to be blue and this one happens to be red, but they both fit what I want. I just want a 4-cylinder with a manual. So how many cars do I have that are what I want? And what is my total? Yes, it is still 8. You still have to count 1, 2, 3, 4. That is still your bottom number. And then don't forget to simplify. The last one, ooh, there we go. The last one says, what is the probability of selecting a blue car with a 6-cylinder engine and an automatic transmission? So it has to be blue with a 6-cylinder and automatic. The red doesn't, we don't want anything that's red and we don't want anything that's 4-cylinder. Good thing about that one, it doesn't even have to be simplified. Your total is still, right? Your total is still 8. Good job. Okay, number 2 is like the second example we did where we're not going to make a tree, we make a list. So, you hear my neighbor's dog barking? Number 2 says, Duncan flips a fair coin and draws a card. The coin and cards are shown here. Use the list to determine the possible outcomes when a fair coin is flipped and a card is drawn at random. So if you look at our list, H is heads and T is tails. So I could get an H and a jack, right? I could get heads and a queen, heads and a king, heads and this jack, or heads and a queen. Right? I could get heads in each one of these. Or I could get tails and a jack, tails and a queen, tails and a king, tails and a jack, tails and a queen. Right? It could happen heads in any one of these or tails in any one of these. So, question A says, how many possible outcomes are there? Well, this is not like a tree diagram. I don't have to count the ends or anything crazy like that. If I look, I can just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then B says, what is the probability of flipping heads on a coin? Well, out of the 10 options, how many have heads as your coin flip? 1, 2, 3, 4, 5. Any others that have heads? Nope. So that's going to be 5. It's what we want. Out of your total, what's your total? Yep, right there. Now you have to simplify. Divide by 5 to simplify. C says, what is the probability of drawing a jack? So again, you're going to find all the ones with a jack. Any of the J is jack, right? This one right here. So you have H and J twice. You count them both. And you also have tails and jack twice. You count them both. So probability of getting a jack, if jack's what we want, how many do we have? 1, 2, 3, 4. So 4 goes on top, and your total is what? Yeah, your total's still 10. That's what you have all together. Now you need to simplify, divide them both by 2. D says, what is the probability of flipping heads and drawing a jack? So it has to be heads and jack. Tails and jacks does not count. So how many heads and jacks are there? And how many do you have total? Still 10. You're still going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can simplify that one by 2. Letter E says, what is the probability of flipping tails and drawing a 10? So tails and 10. So we don't care about any of these with the H's. Tails and 10s. How many tails and 10s are there? There's not any? So how many did you count? 0 out of? So 0 out of 10. There is no way you can get tails and 10. Because there are no 10 cards, right? So when you simplify this, your answer is going to be 0. Now when you finish the rest of your problems, it's not very many. It'll go pretty quickly. Number 6 is probably the trickiest. Remember, you don't have to do them in order, but I would save number 6 for last because that's probably the trickiest one you have today.